Hello, my name is Ben, and together with Mark, we designed and developed the ChargeUp app, which is a EV charging finder app. I worked on the front end and styling, and Mark worked on the front end styling and the back end. Despite this increase, EV charging station locations are not as obvious as traditional petrol stations. This is where ChargeUp comes into play. Using API data from the UK government website, our app allows users to search, filter, and then render markers on a map displaying where their nearest charging station is. ChargeUp provides a clean, simple solution to finding your nearest charger. Now we'll discuss the main features of the app. ChargeUp is designed to be a simple-to-use, straightforward search tool to return charge point information in an easy-to-read manner for the user. Information such as whether or not the EV charger is free, open 24 hours, or currently in service is rendered in an easy-to-understand info window in the map, which you can see an example of just here. Information such as the street name, postcode, and building name are also rendered where applicable. Okay, so next I just want to quickly talk about how we designed the app. The first step was to decide the requirements of the app and how to map it out. We did this and then the next step was to decide which components were required. This was designed using a component tree. Again, we used Figma to do this. You can see this down below here. Mark and we communicated using Slack, and we continue to do so throughout the duration of the project. And now I'd like to talk about the front-end technologies. For the front-end technologies, we decided to use React to build the interface, as this was a technology we were both comfortable with. We implemented Google Maps API from Google Cloud, which allowed us to render a map on screen, map markers, and info windows. Neither of us had used Google Maps or Google APIs before, so this was a new technology that we used from Google Cloud. Whilst we were somewhat familiar with the concepts of APIs, using one from Google Cloud was a new experience. To navigate through the server side of the project, we used React Routed DOM, which allowed users of the app to navigate through different pages of the application. Okay, now I'd like to demonstrate how our app actually works. The first thing a user should do is go to the sign up page, which is just here. They should then log in their details. So for name, support shall be email.com, password, we'll just go for password 123. All passwords get hashed, and create a user. Once your user has been successfully created, it then takes you to the main dashboard, which is then rendered with a map. We have two search parameters here, one for the area and one for the search radius. If the user searches Manchester, for example, with a search radius of 3 miles and then clicks on find, it should then search for all charging stations within 3 miles. If you hover over a charging station, you can see the name of the street, the name of the building, and the postcode. It also gives you the status, whether or not it's paid, if it's open 24 hours, and the charger status. As you can see here, these change depending on the status of the actual charger itself. Each one of these buttons acts as an independent filter, so if I was to click this one, for example, it filters out the results. If I click this button, it filters them out again. If I was to click this button down here, it removes the search form. If I click it again, the search form returns. Up here, there is a button for account where you can edit your user details and you can create a new car. All this information then gets sent to the backend and to a database when you return back to the dashboard. And then up at the top, there is a logout button, which then takes you back to the main page.
Hello, my name is Mark Whitehead, and I was responsible for coding the back-end part of the project, as well as some help with the CSS on the front end. Now, why did we use ChargeUp? Well, the UK government has announced an electric vehicle infrastructure strategy, which aims to end the sale of all petrol and diesel vehicles by the end of 2030. At the end of 2021, there'll be roughly 400,000 EVs on the road in the UK alone, and by 2024, there'll be an estimated million plus. As the popularity of electric vehicles has increased, so has the need for charger infrastructure. From December 2021 to 2022, there's going to be a 31% increase in EV charging points across the UK, and there are currently 37,000 charging stations across 22,000 charging sites. There are three main search functions that generate results in ChargeUp: location, search radius, and charger type. User authentication has also been implemented to allow users to create an account and password. This information is stored in the database and can be accessed when editing user details. Right from day one, we were sure we wanted to use React as our front-end framework, but we were unsure what we wanted to use for the rest of the app. After a few days of researching different technologies and sketching out the app on Figma, we decided on the MERN stack. This gave us the best choice of implementing our ideas within the time frame that we were given. We've used VS Code as our code editor, and we've become comfortable with its features over the last 6 months, and switching to a new code editor now would have wasted precious time at the start of the project. Being only 2 people, we used a mono repo, which was managed through GitHub. This also came with its own challenges. The server was created using Express, which handles all the routes and logic. Mongoose was used to create, among other things, all the user models, and requests to the server during testing were handled in Postman. MongoDB and Mongoose wasn't something we'd previously used, but found it to be more friendly than MySQL and Docker. We found the documents to be thorough and complete. Using the MERN stack allowed us to use JavaScript throughout the whole stack from client to server, and CRUD operations were implemented using the Mongoose library. Using Mongoose allowed us to define our data models and to validate them before saving them to the database. I'd like to do a quick review of the code I've written to get requests to move from the front end through the server and to the database. On the left, we can see the file tree where we have our controllers defined, models, routes, utils, and finally the server. The first one I'd like to look at is the user models, where we have our schemas. The first one is the user schema, which we use to create a new user, which has name, email, password, and password confirm, which is later removed before it's sent to the database. In authorization controllers, this is where we export our sign up request, which is passed through user route, where all our routes are defined. This goes on to server, which uses the path user and takes user router to handle all those requests. One of the main issues we had initially was the fact that we were using Google API that was out of date and had poor documentation. It took us too long to realize this, but despite that, we managed to overcome the problems we had with the API, and we got to start rendering markers on the map. If we'd had more time, we would have loved to have made it so that you could navigate to those markers. They had more advanced search features and gave more information back relating to the type of card that you'd saved in.
I'm now going to quickly discuss the code rundown for the front end. Here we have the file tree where we have the components. We've got app.js, we've got dashboard, footer, header, we've got landing page, we've got map, plug type, and search. So in search component, we've got a handle submit at the top with a get data function is using a fetch API, which is just here. It's making a get request to an endpoint of an API with the post town and the distance value being passed as parameters, which is just here. You can see that there and there as well. When the handle submit is clicked, which is done by this button here, just here, the set charge site state up here. This is updated with the results from the call to the API. Next, I'll just quickly show you the maps component. So on the map component, we have a user cohorts and the charge sites, which are passed as props. The user cohorts have been passed from dashboard and is used to send to the map on the user's location. Charge sites is an array of charger locations. These locations are then rendered within marker F, which is just down here, using the map method So you can see charge_sites.map just there. A useStateHook is also managing state when the mouse hovers over the marker. So we've got mouse over just here. So we've got information such as the street name, we've got the building name, and they're also displayed when the mouse hovers over the marker. So all this information is taken from the API that we rendered in the search. We also use React icons just up here, and we pass these down in here. We set up functionality for users to enter car details, which would have been passed through to the backend, but due mainly to time constraints, we were unable to implement this. If we had more time, we would like to have done more testing. Whilst there are a few tests, we feel the project could have benefited from more robust testing. CSS improvements. Overall, we are both happy with the way the project is looking, but we would refine it if more time was available, as we ran into a few issues towards the end, especially with the plug type buttons.